So here we're going to talk about fractions, and I'm going to focus on different ways to write equivalent fractions, or fractions that represent the same number. So let's start with 1/2. If we draw a picture, say we have a pizza, and we wanted to represent half of that pizza, we might cut it in half and then shade half the pizza to say this is 1/2 of the pizza. There are other ways that we can cut up the pizza and still end up with half of it. So let's pick a different color. Let's say we have a pizza, and instead of slicing it into 2 equal parts, we slice it into 4 equal parts. And if we still want half of that pizza, we just take those 2 quarter pieces. So another way we say 1/2 is by writing so that we have 4 equal parts, 2 of them are shaded, and so we have 2/4. But 2/4 is also the same amount as just the 1/2 of the pizza. So let's say we wanted to slice this pizza up another way and still end up with half of the pizza. And instead of slicing it into 4 equal parts, we'll go for 6 slices, and they're all equal. And if I have 1, 2, 3, 4, 5, 6 pieces, and I want to shade off half of that, I've included 3 of those 6 pieces, so that's 3/6 of a pizza is also 1/2. And then let's say one last example. We have our pizza, and we want to slice it up into 8 equal parts, 8 equal slices, more or less. And again, we take half the pizza. That ended up giving us 1, 2, 3, 4 equal slices out of 8, or 4/8. Now, one thing you might notice in each of these examples is that we've used half of the pizza. In each of these cases, we've indicated, well, that's kind of terrible. Each of these cases, we have half the pizza. I'm having trouble here. Let's just say, let's do it this way. Each of these pizzas is half of the entire pizza. So in other words, what we've shown here is that the fraction 1/2 is also equal to the fraction 2/4, which is also equal to the fraction 3/6, which is also equal to the fraction 4/8. Let's see why this is true. We showed a picture of how this is a reasonable equivalency, but let's see why this is true algebraically. So if we take a look, let's start with the 4/8 and work our way back. If we have 4/8, one way to simplify a fraction or reduce it is to take a look at the common factors in each of the numerator and the denominator. So if you factor out 4 as 2 times 2, and you have 8, which is 2 times 4, then you'll notice that the 2's, you have 2's that can cancel, and you're left with 2/4. And you can do this again. If you have, which is right here, 2/4. So if you factor again, 2 times 2 on the bottom, you end up factoring and canceling, and you have a 1/2 at the end. So you've just shown in several steps that 4/8 is equal to 1/2. Now, we used an extra step in the middle because we didn't completely factor all the terms. This 4 wasn't completely factored. Excuse me. Another way we could have done this is to consider factoring both the numerator and the denominator completely into what's called a prime factorization, or expressing it so that each factor was a prime. So you're looking for prime factors, and remember, a prime would look like any number that has only 1 in itself as a factor. So you have 1, 2, 3, 5. 4 doesn't work because 2 times 2 is 4. So that's a number other than 1 in itself that goes into it, since 2 goes into it. 6 is not a prime because 2 goes into 6, and 3 goes into 6, and so you have numbers other than 1 in itself. So 7 works. 9 doesn't work, since 9 is 3 times 3. I've picked 2 numbers other than 1 in itself that give us a product of that number. So 11 is the next number, and so on. There are infinitely many of these. So what we want to do is get 4 factored so that we've written it all as a product of all primes. All of them are primes. So then 8 is 2 times 4, but 4 is not a prime. So we need to factor out 4 further, so you have 2 times 2 times 2. Now we can do a complete cancellation. The 2's cancel here, and the 2's cancel here, and we're left with just 1's. And 1 times 1 is 1, and we have just a factor of 2 down below. So in one step, because we wrote out all the factors in prime factors, we end up doing one quick step with our reduction, or reducing the fraction. Okay, so now going with, let's try an example. Let's say simplify the fraction 4/36. So it's reduced as far as it goes. So what we want to do here is, as we did before, we want to factor the numerator and the denominator completely. So 4 is 2 times 2. Now 36, a lot of different combinations. One you might have thought of as 4 times 9. You might have thought of 6 times 6. I'll just say 4 times 9. Now, are 4 and 9 prime numbers? No, we can factor 4 a little further. We can say 4 is 2 times 2, and 9 is 3 times 3. And now all of our factors are primes. So now we can completely cancel out anything that shows up in both the numerator and the denominator. So 2's cancel here, 2's cancel here, so we have a 1 factor and a 1 up here, 1 and 1. So then we have 1 times 1 is 1, and 3 times 3 is 9. And so 4/36 is also equal to 1/9. Now one last thing, let's go the other way. Let's say we wanted to find, let's pick a different color here. Let's say we wanted to find an equivalent fraction, find an equivalent fraction for 3/4 that has a denominator of, let's say 24. So now we're going the other way. We're starting with a fraction 3/4. And we want to get to a fraction that has a denominator of 24 and is equivalent to 3/4. So we need to think about what number did we multiply 4 in order to get 24? Well, 4 times 6 is equal to 24. So in order to get an equivalent fraction, what we need to do is multiply, let's pick another color here, let's multiply 3 times the same number we multiplied in the denominator, 3 times 6. And 3 times 6 gives us 18. Let me pick a different color here. Go back to the original. 3 times 6 is 18. So 3/4 is equivalent to 18/24.